Hello and welcome back. In this video, we'll look at the text classification using TensorFlow-hub pre-built model. And the text is going to be movie reviews. And this is coming from the IMDB dataset, which has around 50,000 reviews. And we'll split 25,000, half of them for the testing and half of them for the training purposes. So for this, we'll need the TensorFlow hub installed and TensorFlow datasets installed. If you haven't already installed it, this is how you would want to do it. Type in pip install tensorflow-hub uh, and pip install tensorflow-datasets. And this should install the libraries if they are not already installed. In my case, as you can see, they are already installed. It says already satisfied. And next, as usual, what we'll do is we'll import the libraries that we need. So the first one is import OS, import numpy as np, and then for TensorFlow we need import tensorflow as tf, import tensorflow-hub, tensorflow_hub as hub, and then import tensorflow_datasets as tf.ds, and then we can look at the versions. And now once again, the code that I'm typing here is directly from the docs, and I should put the link here, which I do, and this is the link. You can navigate to that and look for additional information. I'm just going to walk through the code and talk what the lines of code are trying to do. And for version, we'll type tf dot underscore version underscore, and then the next one print, and again in quotation you have eager mode, and we have, and here tf dot executing underscore eagerly, eager ly, open close parenthesis, and then we have print hub version, hub dot underscore version underscore, and finally we have print GPU is, and I'm not using a GPU in this runtime right now, available, but if we need it, I'll switch it to GPU later on. tf.config.list underscore physical devices, and here within parentheses we specify the GPU, else again in quotation not available. And so let's run this, and as you can see there's no GPU, and in the runtime if you look at the change there's no GPU that I've used. So let's keep going, and next I will look at how to download the dataset. So create a heading here, download the IMDB dataset, and for this we are going to split like so. So here's what we are going to do. The first, we have the training set. So train set, we are going to put 60% in that, and then for the after that we have the validation, or validation. This is going to be remaining 40%, and let's say 40% here. This is going to be around 15,000 records for this, and this is going to be around 10,000 records. Okay, and finally for the test set, so that's total of 25,000, and for test set we have a separate set of 25,000 records. So for here we'll use the tfds.load. So for that, we'll be getting train data, validation data, and the test underscore data is equal to tf.ds.load, and here name is equal name of the data set is IMDB underscore reviews, and then we'll split, this is going to be the split is equal to open close parenthesis, and we have 1, 2, and 3, and here we have the train that goes to 60%, and so that's the closing parenthesis, should be open parenthesis right here, open parenthesis 60%, and after that we have the remaining stuff from the train that goes for the validation. So from 60% onwards, that goes to the validation, and finally we have the separate test dataset. And below this, we need to write as underscore supervised is equal to true. Let's run this, and while this is running, so this is already done, and we can now look at the shape of the number of records that we have in each of these. So usually in when we are working in pandas, we would simply write train underscore data dot shape, but in this case, because if you look at the type of train underscore data, this is a prefetch data set, and so if you type train underscore data dot shape, it's not going to work. We'll get an error that says prefetch data set has no attribute shape. So what you want to type instead is experimental cardinality, and we'll write that here, print tf.data.experimental.cardinality, and within this we'll specify the train underscore data, and we'll copy this and paste it 3 times for the validation, one for the validation set. So let's type that out, validation, and then finally we have the test data. And so when we run this now, we should get the records. So here, as we expected, we have 15,000 for train, 10,000 for validation, and 25,000 for the test set. Let's now explore the data and see what the reviews look like. So explore the data, and what we'll do is we'll try to get the first 10 records of 10 examples, and for this we'll use the train data set. So train underscore data dot batch, we take 10 examples, and then we are going to put that inside of iter, and then we are going to put all of this inside of next, and this will get us the values. So train underscore, and we'll put a is equal to here, and now here we type train underscore examples underscore batch comma train underscore labels underscore batch, and then below this we'll type train underscore examples underscore batch, and so that's you should see the movie reviews, and these are the reviews. And below this, let's get the labels, and the labels here indicate that 0, it's either a positive or negative review. So 0 indicates a negative review, and 1 indicates a positive review. So let's write that down. 0 indicates a negative review. This is a classification task that we are working at. Positive review. Okay. So 1 for positive, and if we put a tab, this should appear as a bullet. No. All right, so let's put the enter there. Now this works. So these are the reviews, and below are the labels for those. Let's get the labels. Train underscore labels dot underscore batch, and here we have these labels. So let's look at the last review. This is the last review, and by the label it is a negative review. So let's look and read through this. Sure, this isn't really a blockbuster, nor does it target such a position. So it looks like this is a negative review as opposed to others that, and it's each of these is a considerable text in each of those, and we are going to use that to perform the classification task. Now, when performing classification on this type of data, there are a couple of points that we have to go through before we when we build a model. And when we use a pre-built model, some of those pre-processing tasks can be ignored. So for example, one of the tasks is how to represent the text. Again, this is, I'm copying this directly from the docs. The second one is how many layers to use in the model. And the other question we have is how many hidden units, to use for each layer. And these are the questions that need to be answered. However, if we are using a pre-built model, then all of this is taken care of, and what we can do is with the models from TensorFlow-hub, TensorFlow-hub, we can use a pre-trained text embedding as the first layer in our sequential model. And what this allows us to do, so the advantages of doing that is we don't have to worry about text pre-processing. No text pre-processing, and we can benefit from transfer learning, benefit from transfer learning, and then embeddings has a fixed size, so it's a simpler process to use. Embedding has a fixed size, so it's simpler to process. Now the model that we are going to use in this particular case, I've already pulled this here, is this model, NNLM-ENDIM50. So let's put that here. So model is going to be this model that we are going to use, and here is the link for that. Again, this link you can find it in the docs. The docs also have a list, kind of suggestions for other alternative models that could be used here. We'll be proceeding with this model. Now, to write the code, here's what we'll do. First, we'll write the URL for the embeddings. Embedding is equal to https://tensorflow-hub.dev/google/nnlm-en-2. That's the model, and that's the URL for that. And then we would use the hub.KerasLayer. Hub_layer is equal to hub.KerasLayer, and inside of this we'll write embedding comma input_shape is equal to open close square brackets, and so let's bring that down there, bring this down, and after input we'll specify the data type is equal to tf.string, and trainable is equal to true. So that's what we have, and all right, that's where, okay, so that's what we have. Now we can look at, so let's run this first, and once this is done we can look at the examples inside of this batch. Okay, so here we'll type hub_layer train_examples_batch, and we'll use :3, and this should get us the embedding. So here's the Here's the first one, here's the second one, and here's the third one. That's what we have. Now we can go ahead and build our model in Keras. So to do that, we'll type model is equal to tf.keras.Sequential, open close parenthesis, model.add hub_layer, model.add tf.keras.layers.dense, and here we input write a value of 16. Activation is equal to relu, and then we have model.add tf.keras.layers.dense, open close parenthesis 1, and then finally we can get the model summary, model.summary, open close parenthesis. So once this is built, this is the summary we have for the model, and total trainable parameters are around 48 million in this case. Now let's compile this model. So for compiling, we'll type model.compile optimizer is equal to Adam, and then after this we have the loss is equal to tf.keras.losses.binary cross entropy, and then here we specify from underscore logits is equal to true, and we have matrix is equal to accuracy, and let's run this. So this will compile our model, and now we are ready to train the model. So we'll put the history in the variable history, and for training we'll type model.fit train underscore data dot shuffle 1000. So we shuffle the dataset dot batch, and we specify the batch of 152 in this case. And the next thing we'll specify is the number of epochs, so 10 epochs. Validation data, and that's going to be validation underscore data dot batch, and again we specify 512, and verbose is equal to 1. So when we run this now, we should see the progress, and epochs, missed the S there. Let's run that, and we should see the progress through the training as here with the epochs. And let's see how much time it's going to take for one run, and it's around 2 minutes, and we have 10 epochs, so this would take around 20 minutes to run. So what I'm thinking is, let's stop this run, and I'll switch the runtime to the one that uses the GPU, and then click on save, go back up. It'll I'll have to restart everything, and that is okay, because it will hopefully save us time. So once that is done, okay, so all right, we do not need to run this cell, but we do need to run the remaining cells. So I'll run through this, and this time we should see that it says that GPU is available. It is. And if you look at the resources, we do have 15 GB of GPU RAM available. So let's run the other train. We have this, and we go through all of these, and finally we should be able to run the training with the model.fit. And let's see where we are at. This is pulling, we are still here in this particular stage. Once this is done, we should be able to see the number of records again. It will be the same number of records in each of these cases. So while that is running, we could go ahead and type the heading at least for the next step that we will need to do, which is evaluate the model. Evaluate the model. And once we have the epochs done, we'll type that out. So here IMDB reviews, and we see we have the same number of reviews here, and we have the examples. Here we are getting the model embeddings from the TensorFlow-hub. And finally, we have the model, and we are ready to compute. And as you can see, it's pretty fast, just 20 seconds per epoch with GPU as compared to 120 seconds using that. So 2 minutes without GPU. So GPU definitely does help. Now, once this is done, we should be in a position to write the code for evaluating the model. Maybe we could go ahead and write it anyways. Results is equal to model.evaluate test underscore data dot batch. We'll use a batch of 512 comma verbose is equal to 2. And once this, let's wait and see, we are at 3. Okay, so we'll then iterate over the results. So to iterate over the results, we are going to use a for loop for name comma value in zip model dot matrix with a s underscore names comma results, and then we have the colon print name and value. So for that, we'll type %s colon dot 3f, and then after that we have the name comma value. So once this is done, we'll run those lines of code, and during the training we can look at how the accuracy is changing. As you can see, we started out with 0.6. We already have reached 0.98 right now, and if we look at the validation accuracy, it has started to plateau right after the third epoch, and that may be, and again, as you can see, the training accuracy has reached 0.9, and that's kind of a classic example where you need to start thinking in the direction of overfitting. So this may be overfitting with this higher training accuracy. And I think in this one video after this one, we'll be looking at how to handle this situation with overfitting. And is there anything we can do? And for now, I think this is what we are going to look at, is a simple case where we use the TensorFlow-hub model in this particular training process. If we go to this website, here we have the model, information about the model. Again, we can also, so this is how we can access it, the same type of code that we've written. Okay, the last epoch, and we are at almost 1. And this is definitely overfitting with the accuracy of 1. Validation accuracy is 0.86. Let's now run the step for evaluating the model on a test set. And test set accuracy again is 0.84, comparable with the validation accuracy, but nowhere comparable with the train accuracy. So that is what we have in this video. I hope in this video you got intuition about how to use a pre-trained model from TensorFlow-hub for text classification, and it's pretty simple to use. All we have to do is create a first layer in the sequential model that uses the embeddings from the pre-trained model, and we do not have to worry about pre-processing the text, such as creating vocabulary dictionary, any of that, and this pre-trained model will handle all of that. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Thank you.